Welcome. In this video, we'll walk through creating a long-span truss and discuss a few design considerations specific to shipping and manufacturing these components. Let's get started. Start by opening the Component Creation panel. Here we will set the length to 64 feet. Next, we'll add a 32-foot profile line, and we will set the slope to be 612. Now click Add Line. To close this component out, we can click the Close Profile option 2 times and move on to the shape details. For this demo, we want the bottom cord to run through the heel, so make sure those checkboxes are selected, and then click Next. In the Structural Details sections, navigate to the bottom of this panel and access the load settings. Typically, these long-span trusses are not used in residential settings, so we will make sure 1 or 2 family dwelling is deselected. Next, make sure Sprinkler Installation Load is selected and click the Apply Along Bottom Cord checkbox. Now click Change the Settings for this component to wrap up our changes to the load settings. Open the Analysis settings and navigate to the Other Settings section. For this scenario, we are going to say the structure has multiple of the same truss, so we will select Use Repetitive Member Increase and click Change Settings for this component. Now we can insert the truss. Let's analyze the truss and see if any checks are over capacity. Select Analyze from the menu to run the check. For all trusses, we want to make sure each connection is where we want them to be. The analysis shows some checks are exceeded. We can see some of our plates on the bottom cords don't have enough grip. Hover over one to show this data. Let's select the bottom cords and upgrade them to be 2x6s. Next, we will right-click, then select Edit Lumber. Here, we will select 2x6 from the list. To see these changes take place, we need to reanalyze the truss. After the truss has been reanalyzed, we can see that this solved our issues at the splices, but we still show that the heels are exceeding capacity. We could upgrade the top cords to be 2x6s, and that would solve the load issue, but that would increase both cost and overall weight. A better solution is to add sliders to the corners of the bottom cord. Click Edit Truss from the Actions toolbar, then click Adjust Heels. Here we can set the left heel reinforcement to top cord slider, and we can do the same for the right heel reinforcement. We will leave the other properties set as they are. Click Close. We will now reanalyze the truss with the sliders added. Looks like this worked. Let's zoom in to one of the plates at the heel. We should see no issues with the plates now that we added these additional sliders. Now we know this truss will work for the given situation, but certain details must be considered when designing a truss this size. Many manufacturers do not have the ability to fabricate this truss, let alone ship it. Shipping limitations vary, so be sure to check your regional requirements. Given this information, we would likely design a piggyback truss to allow shipping and on-site assembly. We will cover piggyback trusses in a separate video. Thanks for watching.